Okay, we're gonna keep moving. We're on a fairly tight schedule. One thing, we're looking for Ryder, Maxime Boisvert, and Michael. If you guys could go see James for the Ignites that are gonna happen after this talk and the break, that would be super. So Ryder, Michael, and Maxime. James is back there, or he can come see you. Ryder's over there, James. James? Ryder's over on that side. Cool. Great. Thanks. So we're going to continue. We're going to do this talk from Yannick, and then we're going to have a break, and then it'll be Ignites and another talk before lunch. So I have the pleasure of introducing Yannick, who is from here originally, but who has spent time in San Francisco and New York recently and is back. So welcome back. Thank you for being here. Yannick is a hardware system engineer at Facebook. So it was cool yesterday. We had Catherine talking a little bit more on the dev side, and today we're going to have Yannick talking a little more on the ops side. So it's some good equity there. So please give a round warm welcome to Yannick.
Merci, Julia. So if you follow the tech news, you probably have seen a headline like those. The first one, some bug happening into the BMC, the board management controller, on some super micro machine that allowed some attacker to get some credential and do whatever they wanted to your machine. If you have that connected to the internet, it means about anybody could do something to it. The second one, Cloudflare did some investigation. They had some random crashes happening to their application. They could not find out what it was. After a long time investigating, they pinpointed the problem to some bug in the CPU microcode. What does these two things have in common? They both happen because there's a bug in the firmware running in some part of the hardware. And they can both be solved by doing a firmware upgrade and running the latest version. So as Julia said, I'm Yannick. I'm an hardware system engineer at Facebook. I work on the firmware automation and management team. I used to be a production engineer, work on the kernel team, also working on deploying newer, shinier kernel across our fleet. So we are DevOps Day. I'll assume that everybody here are getting pretty good at deploying fast, deploying frequently, mainly your main application. If you're good, you're probably doing that for the same for your infrastructure, deploying your operating system, and even keeping your kernel up to date, if you follow my talk in the previous years. But have you thought about the firmware? Have you thought about the software running inside your hardware? Hopefully, I hope after Steve's talk that you are getting way more time and you can start focusing on that. Quick show of hands, who here actually manage real hardware, own hardware, do some of that? There's a few. I was expecting that over the years, more people are running to cloud. Obviously, if you don't have hardware, you don't have to worry too much about firmware. But one thing you should worry about and verify is when you choose a cloud provider, do they maintain their hardware properly? Do they apply all the updates, make sure everything is secure? So it's a question you should ask and make sure everything is good. Another question. Who here have heard about the Open Compute project? There's a few more. That's good. Who here run Open Compute hardware? Yeah, that's what I'm expecting. The Open Compute project was started in 2011 by Facebook and a few other partners to provide an open platform. Like basically, we bring the open source movement to the actual hardware for the data center. So coming from the actual server to the whole data center design, all the specs, all the design, all the schematics are available to the Open Compute project. That's the hardware I'm more familiar with, so most of my example will come with from those hardware, and if you want to find the spec and the schematic, it's all available on the OCP website. So, where can we find the firmware? There's a lot of them, and I'll go over the various sources of firmware. The first one, I'm pretty sure everybody have heard of it. Everybody have done BIOS upgrade either on some server, on some desktop, your laptop. It's pretty familiar. It's been there for almost ever. These days, it's not really a BIOS anymore. We use the UEFI subsystem, but the functionality is the same. Starting the hardware, initializing all the various components, passing the control to your operating system. But that's not the only component living around your CPU. If you have some MTL chips, there's a thing called the management engine, which is a small part, a small software running on the CPU that provide sensor information to other component or allowed you to do like rebooting your CPU and other hardware operation in there. That's not the only one. Your CPU also has a bit of firmware running in it. I mentioned earlier at the intro the CPU microcode. It's a piece of software configuration. It's not as a classic view, but it's something that can be updated. And it's responsible to decode the big Intel x86 instruction into smaller components that the silicon can actually operate on and do things. If you go around, we look at the motherboard, there's a lot of components around that has firmware, things like PCI switches, USB controller, and many more. Even like things like voltage regulator that make sure the power you get into your motherboard, into the CPU is right, can have a piece of software and can be upgraded over time. Can be a bit scary if you mess that up. You might burn your disk, or you might burn your system, but you don't want to mess that up. Also, on the motherboard, there's a thing called, I mentioned earlier, the baseboard management controller, the BMC. It's a really essential component if you're in a data center. This component allows you to go around and do remote operation on your system, either rebooting machine, doing some power control, you read the sensor, and control various components on your device. It's a really critical component. Since it's connected to the network, you want to manage that properly, as I said at the beginning. Network card, another like pretty common and pretty obvious that we need to upgrade firmware. Everybody has probably done that at some point. It's one that we upgrade quite frequently. Firmware can be quite complex, especially in that case of networking. Networking is a big operation. There's many protocols around. There's even just the TCP protocol can be quite complex. And in many cases, not just in case of network card, the firmware will contain a full operating system. In some cases, it's going to be a small real-time operating system fitting in a small chip. But in some others, it's going to be a full-blown Linux system with all the same stack that you have in your server. So things can get quite complicated in case of firmware. Storage, yes, also contain firmware. It's not just a black box storing disk, data. What do they do? If you have like good old rotating disk, firmware might be responsible to reorder the requests, manage the queue properly, and order them to make the operation in smaller chunk, not smaller chunk, but together, so the read head doesn't have to move too much when you want to get your data out. If you have SSDs, more modern world, also there the firmware has various roles. For example, will spread the read across the whole flash, so you don't burn out some specific part of the disk, and make sure you wear the disk levelly in a level way and extend the life of your hardware. There's other components like RAID controller that also have firmware that needs to be updated. A lot of people these days do AI, and when we do AI, we usually talk about GPUs or some like specific ASICs. Yes. If you run GPU on your card, on your desktop computer for gaming, you probably have done software firmware upgrade at some point. One thing I want to highlight here is doing a firmware upgrade and enabling new feature there might actually need a kernel upgrade, a new driver in there. And you might even need to update your software stack, the library on top of it. And the other way around, you might want to use the latest library because there's some shiny new feature. And that might require to go and upgrade your kernel and then upgrade your firmware underneath to get the full potential of the hardware. And there's a lot more. I didn't talk about the network device, switches, router, backup, UPS, power supplies, tape controller. There's quite a bit. Even like, I even touching like building control, like your AC system, temperature control, anything else. There's a lot of stuff going in the building, even in the colo operation, or if you store some machine in your office, that might software if you have any some remote control to them. So we've seen what are the various firmware in there. But why should we do DevOps? Why should we care about like these low-level software component in our fleet? The first main reason is it's software, it's part of our stack, it has an impact into your end application. So we should consider it when we deploy our application. But there's a few specific reasons I want you to think about. First one, security. These days, it's a pretty hot topic. We want to make sure nobody has access to data unwanted. Keep your system secure. Don't do anything unwanted. As I talked earlier at the beginning, BMC can have pretty deep access to your system, and you want to keep that secure. There's authentication protocol. You want to make sure you're running the right version, apply the security patch to them. Most of us have probably heard of the Spectre meltdown issue on the CPU, where some neighbor VM could access some of your data. That specific issue might not be able to be fixed by some microcode update, but similar issue might be. And you could just get the newest microcode for your CPU and fix some of those issues, some of those security issues at the CPU level. I talked at the beginning about some random crashes. Obviously, that's something you don't want to happen. I'm pretty sure nobody wants some application disappearing or some machine just rebooting for no reason. So you want to be able to fix your hardware and make sure it doesn't affect your software stack. Even things like at the network level, if you have a bad network card, a bad firmware on it, it might cause some packet corruption, just making packet invalid, just getting dropped on your system. Close to bugs, instability, performance. You don't want your system to crash, but you also want your system to run at full throughput. I imagine everybody here want to have like the full memory bandwidth, for example. I've seen cases where a bad configuration in the BIOS, on the management engine, have caused the system to initialize the memory bus at a lower speed, and thus not giving us the full performance application. We discovered that by running some benchmark and saying that some machines were faster than others, and the only difference between those two was a different firmware version. Another issue we've seen, causing performance issue, some stall causing from some SSD device. We're showing a bunch of trim operation, basically telling the SSD that it can delete some blocks. The SSD decided to do them at some point in life, all in a big bunch, and when it started doing that, stopping responding to any other requests. Can be quite fast, less than a second, but for an operating system, that's a really long period of time. We're able to work with vendors, get an update on the software, and get back the performance of this device. And you might want also a bunch of new features. One thing, you might get like a BIOS update that gives you much better power management, allowing you to save a lot of money in electricity cost. You get some new thing like new network protocol coming up every day these days. You might want to enable some new NIC offloading to enable some subpart of the protocol at the hardware level instead of the operating system level. Or, I mentioned SSD, you might get just a better wear level algorithm to spread the disk properly, get you better performance out of it, and just extend the life of your disk. So there's a lot of those reasons that we care. And I hope at this point, I might have convinced you that firmware is something we should be thinking about when we think about our software stack. So in the next, I'll go over how did we solve, or how did we manage firmware at Facebook. I will not go over into all the really low-level detail, all the implementation. It's not the important part. I'll just go over the high-level view of our solution and what are the key components if you want to implement a solution on your own to manage firmware. So this is the basic flow. We receive firmware, usually from vendor, we package them, we do validation, and we deploy them. Pretty simple. Let's go deeper. So we deal with a lot of different firmware, a lot of different devices, a lot of different vendor. Most of them will all have a different solution to provide firmware. It can be a binary file, will be a zip file, can be an executable file. So what we decided and what we realized was really important is to find a really common format for all those firmware. So when we receive firmware, we package them the same. We basically have a compressed file, some meta information, some tool that goes with it. So all the rest of our orchestration only have to deal with one file format. So we can have the same tool for everything that goes around and apply firmware upgrade to the fleet. Version database. You want to know for each asset that you have, what are the firmware running in them, what are the current version. You don't want to have to go and query each machine by one by one. You probably want to store that somewhere. And you also want to know and configure somewhere which firmware version should be running on each of the machine. You might have different generation, or you might have like the same network card in different generation of hardware. You might not want to apply the same firmware because of different reasons that you'll discover during testing. Yes, every vendor do thorough testing before releasing a software, so you can trust them that it's going to work. But it might not uncover some really specific corner case that you might have in your application. You might have some really, really high-performance application that stress the disk to the really high level. And the change in the software on this disk might change the performance characteristic and create some issue on your platform. So you don't have to redo all the validation that the vendor has done, but you should at least test your critical application when there's a new firmware available for your platform to make sure it doesn't impact negatively your workload, either on performance or creating like crashes, things that would impact the end user at the end. And finally, when you're ready to go, you need to be able to deploy it. I used to talk a lot about that, about kernel, and it's about the same story here for firmware. It sounds easier. You have a piece of software you can just deploy. But for many, it's kind of hard, and it took us years to develop a good infrastructure where we can do that. The first thing to know, you need to plan capacity into your fleet. If you have like a number of machines, you need to be able to take down the percentage of it to be able to do operation. Maybe it's only at night when you don't have many users, but you need to reserve some time to do some firmware upgrade, but also a bunch of hardware maintenance, kernel upgrade. Maybe you need to change the OS at the low level where you can then, or even just your Kubernetes controller or things like that, where you need to remove all your traffic from some specific machine. You need to be able to reboot any machine that you have. Sounds a given, but sometimes you'll be running one application that have some really critical component, and you'll get people to, oh, I cannot reboot that one. There's no, I don't have redundancy. I cannot do that. I'm hoping that these days it's not a problem. People build that part in the architecture, but something to think about when you have to design a new architecture. Can I take down this machine at any moment? With some add notice, but you need to be able to do that. And as you deploy, just as a safety general recommendation, you should that like in some way of canarying or sharding. Make sure you don't deploy to the 100% of the fleet. We've done that a few times. Realized that after it was deployed to most of the machine, BIOS was bad. You had to go and revert because some problem only happen when you put them in production, sadly. So you want to take a small chunk, go to 5%, go to 10%, 50%. You don't have to do like all each 1% percentage, but at least get some baking time in production before you commit to the full release. So far, talk about vendors, and most firmware come in a binary blob format. If you're used to dealing with open source operating system application, that's pretty annoying. You get a big black box, and then when you have problem, you have to call somebody to have it fixed. Luckily, things are changing, and there's a bunch of open source firmware and tooling solution that's coming up. The first one I'll mention is the Core Boot Linux Boot initiative. We are contributing actively to that, and that's basically a replacement to the BIOS UEFI subsystem with an open source solution. There's not a lot of hardware supporting it yet, but there's more and more vendor coming and collaborating and giving us support in there. That also comes with an open source tool called FlashROM to replace all the binary application to go and flash the chip. FlashROM can support about all the flash and component out there where you can flash a BIOS. So that's a good step about having a standard tool to that. This is the general architecture of like a Linux boot system. And the idea here is you have like you have a low-level initialization component, usually core boot, that might still contain a really small binary blob coming from CPU vendor that will enable some component that they cannot share. But usually the idea here is that small binary blob should be redistributable. Anybody could package it into their core boot image. So when the hardware is initialized, the memory is initialized, core boot passes the control to a Linux kernel with a really small user space component, and then you can do much more complex operation that you can do right now with UFI. UFI, you can do some PXE boot to boot some remote image, but since you have a full Linux there, you can do maybe complex authentication before you load an image or whatever operation you want to do. It's open source, you can bake whatever you want in it. And then it loads like some random operating system. Doesn't have to be Linux, can be any other operating system. There's no distinction there like as any other BIOS. I mentioned OCP earlier. They announced this year that the open system firmware, basically the BIOS, will need to be open, will need to be part of the requirement to have your stamp as an OCP approved hardware in the coming years. Why is it important? There's two main reasons. As I mentioned, as a developer, you want to be able to play with your hardware, find a bug, or even improve features. But there's a really critical component is to be able to support the hardware in a longer time frame. Most big companies, Facebook, Google, all these ones, might run hardware for 3-4 years, and then usually get decom. But this hardware is usually not thrown away. There's company taking this hardware, repurposing them, and reselling them. But the big hurdle they have right now is all the firmware components that they have, usually the original vendor don't support it anymore. If you have an open firmware, then those companies can support it for a really long period of time. IT Renew have announced they want to be able to support for an additional 6 years new hardware if they're able to get some open firmware in there. It's really critical because the carbon impact of data center you might think is the electricity, but 3/4 of the environmental impact of the carbon impact comes from the manufacturing of hardware. So if we can extend the life of each hardware, we can lower the environmental footprint of every data center that we have. OpenBMC is another project where we contribute. It was started separately by Facebook and IBM a few years back. Basically, it's an open version of the BMC controller. In this case, we run a small Yocto Linux image and allow you to do also a bunch of operation that is, it used to be limited on the BMC that you can only talk IPMI, a really strict protocol. But with BMC, you can just SSH the machine and do whatever control operation, remediate hardware error automatically at the BMC level without having to rely on your operating system. We were able to do things like unstuck, some machine would get stuck, some load, or some issue. We're able to come in the BMC and have some auto remediation doing that directly in there. And there's other, like a company like Netronome has announced that they do network cards, and they're gonna release their network firmware openly. There's things like OpenSSD, more like a research project, but provide the same open firmware for SSD, this device. And I even talk about other platforms. There's the same for ARM, PowerPC, Spark available. On the tooling side, if you run a Linux laptop, you might stumble on that. The Linux Vendor Firmware Service, it's an initiative to collect firmware from different vendors and have a common way to apply firmware to your Linux device. We are not using it because it was not really available when we started our initiative, and there's a few issues that make it more tailored to the desktop than the data center control, but there's a few good ideas there. They are using a common packaging format for every firmware. That's a good start. They separate the downloading of the firmware and the applying to a firmware app daemon. But there's no thing like orchestration and testing that you need into your data center. But for your laptop, it's a really good, welcome initiative. If you're in Linux and in the past you had to boot different operating systems to apply your firmware, this is a good start in the open source world. So I'll give you 2 takeaways before I leave. First one, the firmware is an integral part of your software stack, your software ecosystem. You should consider it part of this thing. It doesn't stop at the hardware level. There's another layer underneath. when I used to work on the kernel, I used to think I was the bottom layer of the stack. And as I started looking deeper, there was actually a full layer underneath me that could create problem. And second, we need more work on the open source side. There's a lot of open source firmware coming up. There's some tooling, but they all need improvement. They all need help. And we welcome any help to improve them. Thank you. Merci. Donc, j'imagine qu'on a quelques temps pour les questions. In French, en anglais, as you wish.
Okay, you can use that mic. Go ahead.
Oui, bonjour. Allô? Oui. Bonjour Yannick. Je suis curieux de savoir, dans ton talk, tu n'as pas parlé beaucoup de l'automatisation, de la mise à jour des firmware. Je présume que certains morceaux de hardware peuvent se faire mettre à jour d'une manière automatisée, mais je présume que ce n'est pas le cas dans tous les cas. Donc, les compagnies comme Facebook et Amazon qui gèrent beaucoup de hardware, est-ce qu'ils s'assurent d'avoir toujours du hardware qui peut être dont le firmware peut être mis à jour d'une manière automatique? Puis sinon, comment ils s'y prennent pour faire la mise à jour d'une grande quantité de hardware?
Pour répondre à la question, je n'ai pas beaucoup de hardware qui se met à jour par lui-même automatiquement. Et généralement, quand tu manèges une grande flotte de machines, tu ne veux pas que le hardware se mette à jour par lui-même sans que tu sois au courant. On veut être en contrôle des versions qu'on met et qu'on déploie. Donc, on ne veut pas que le hardware, magiquement, un jour, se connecte sur Internet et se mette à jour par lui-même. Donc, on veut vraiment avoir des outils. Mais on a construit toute une suite d'automatisation pour scanner notre flotte et mettre à jour chacune des machines une par une. Généralement, ce qui arrive, c'est qu'on shut down la machine, on boot dans une image simplifiée, on applique tous les nouveaux firmware qu'on a besoin et on reboot la machine, on remet en production par après.
Puis tout ça, c'est automatisé? Ça peut être
Oui.
automatisé?
L'idée, c'est d'avoir... Je parlais de déploiement, je ne l'ai pas mentionné, mais le déploiement est maintenant à 100% automatisé. Tu ne veux pas avoir quelqu'un, tu veux vraiment... Une fois que le firmware est validé, on met la case à OK et il va trouver les machines qui ont besoin d'être uploadées, drainer les machines et appliquer le nouveau firmware.
Exactement la même question. Est-ce que tu as un lien, des exemples qu'on pourrait utiliser pour automatiser le plus possible les upgrades de firmware?
J'ai pas de code et j'ai pas nécessairement de plateforme parce que tout est lié à notre orchestration interne. Ce que j'aimerais voir quand on utilise notre propre outil de container, un outil qui s'appelle Tupperware, j'aimerais ça voir une solution, par exemple, intégrée à Kubernetes ou quelque chose qui pourrait avoir une orchestration intégrée. Je pense que c'est une demande dans la communauté à faire au niveau open source pour construire ce problème. Le problème de management firmware n'est pas un problème qui était très regardé au niveau de la gestion des centres de données jusqu'à tout récemment. Fait que c'est pas un truc qui est beaucoup dans les outils disponibles. Normalement, les solutions n'est pas très compliquées. L'outil qu'on a, le code n'est pas très gros. C'est essentiellement un truc qui scanne la flotte. Regarde, on a une base de données qui dit pour chacun des types de machines quel firmware qu'on veut. Il fait juste scanner la flotte, regarde, OK, cette machine-là a besoin d'un update firmware. La seule contrainte qu'on a, c'est pour chacun des services. On a un certain nombre de pourcentages de machines qu'on peut mettre down pour ne pas affecter le service en fonction des buffers, de la capacité de buffer qu'on a. Et ça continue comme ça à travers la flotte. Donc, ça n'a pas besoin d'être compliqué. Il faut juste avoir une certaine capacité de buffer pour pouvoir gérer ces mises à jour-là.
Il y a une question de ce côté-là.
Thank you for this talk. Finally, something for the ops guys. I had a question about testing. I mean, do you have like because testing software is relatively easy, but testing hardware, do you have like a lab with each version of your hardware, firmware? How do you do for testing, for example?
Yeah, good question. We do have both kind of testing. We do some we have a lab with some of usually each sample of the hardware that we have, usually like every year, every 2 years, we have a new generation. So we try to keep sample and do some, I would say, manual validation when we receive new firmware, especially if it's a new component, is more critical. We usually follow guidelines from vendors in that area. And we are developing a set of suite to do some firmware validation that should be open source now or will coming quite soon. That we can share with vendors to do validation. But that's the first step. But we also just do testing in prod. We will take some machine in production, either run just pure benchmark, not put them in production right away. But we love to, one thing we do a lot is like shadow traffic testing. So if you have a critical application, we'll spin up the same machine, the same hardware, put 2 different firmware side by side, and just send the same traffic to both machines. The old one will respond to the user. The new one will just drop the answer. But we'll see if the performance characteristics are the same for both.
We're going to have one question here, and then we'll come back to you.
Thank you very much, first of all. And can you mention some of the vendors which are friendlier than others to this open initiatives that
Sorry?
you mentioned? You mentioned some vendors which are starting to work on more than others. Can you mention some of them by name, I suppose? Can you recommend some, I guess?
There's not, I don't think you can buy hardware yet that has open firmware for the server. I know there's some laptop that are coming. We've seen HP at the last OCP Summit a couple of months back, came with one of the HP server booting an open source firmware. So it's a good experiment. It's still at the experimental stage. I'm hoping to see the next 6 months, a year, to see more and more platform and people advertising platform. Obviously, if you find any vendors on the OCP website, there's a bunch of vendors where you can find hardware from, like WeWin. I know it's one that is there, that we've been working, collaborating with in some aspect. There's a few other. You can find the list in there.
Cool. We'll have one last question over there.
Yeah, just an example of the relevance of the importance of knowing about your hardware and your firmware. When the spec meltdown issue came with the Intel processors, I think it was a year ago or something like this, our internal cloud provider had to patch the BIOS, and it broke the nested virtualization that we had been using on the virtual machine. So even as a developer, we had to go back to our cloud provider and ask to troubleshoot this so that we could pursue and using our nested virtualization. So it's really pertinent. I mean, it's a cloud, it's somebody else's problem, but sometimes it can become your problem also.
It's a good example. It's a good example where validation is important. I've seen an example where we get a new BIOS, there's no performance changes, but for some reason there's a setting that got switched and like disable or enable something. It was like, oh, we needed that on some machine. It wasn't in the spec. We provided the vendor to have this setting by default, but it just got swapped because it was like not a required setting, but some people were relying on it. So doing validation was important for that aspect.
Hey, do you have a way to bake in all the settings that you would configure in your BIOSes? I mean, I hate dealing with hardware because it's always proprietary and I can't get code and vendors won't give code, but also it sucks to have to, like, you know, physically go at a keyboard and click the virtualization extensions button and all that other stuff. Is there a way to set that up as code?
Not really. It depends. I would say use Linux boot and core boot. That will allow you to do much more advanced setting. There's something you can do with UEFI, enable some of those settings in there, but most of the cases you have to rely on like vendor tool. Like for example, for the VT instruction, we have to rely on the vendor provided tool, and through our chef automation, we enable it or disable it. But there's no yet open way to do that with some standard tool, and I'm hoping to see more of that coming up.
So you have an employee that every machine comes in, has to plug in a keyboard and click through your BIOS settings times like 100,000 times or
hopefully
more?
not. You can do that with your BMC. So you can do that remotely and access the BIOS through the BMC. You can get a virtual console via the network. So at least you don't have to do that way.
So he's in a VNC terminal on his own keyboard doing this 100,000 times.
Yes, sometime.
No.
With some bad hardware.
No more questions, James. You're cut off. OK, ben, merci beaucoup, Yannick. Thank you.